Hello and welcome to A Level Math. Today's topic is the extension of the chapter sets that we covered in the first module. In this module, we are going to extend the concept of sets to the notions of subsets and supersets. So, what are subsets and supersets? So, think of a set like this. You're given A is equal to 1, 2, and 3. So, these are the three elements of the set A. So you can take any two or any one of these elements, right? So you can form sets like 1 comma 2 or 2 comma 3, or you can just take a single element 3 or all of the three elements or anything. So you can make many sets out of these sets of out of this one single set A, right? So all of these smaller sets are called the subsets of the set A, and A is called a superset of all these sets. So why I am saying that A is a superset and all these subsets are subsets of A, because they might not be unique. There can be many subsets of a given of a given set. I'm sorry. So let's see how we can formally define a set, a subset. So a set A is said to be a subset of set B if every element of A is also an element of B. So you will say that A will be smaller than set B. Actually, it should be a subset. We don't use the word smaller, it's just for your understanding. So A is a smaller set than B, or A is called as a subset of B if all those elements that are there in A are also there in B. So the definition requires that all of the elements that are in A has to be there in B. So B can have some more elements as well. Say for example, if A is having 1, 2, 3, and if B is having these three elements along with some more elements, then B is bigger than A. So we can say that B is a superset of A and A is a subset of B. So the smaller set is called the subset and the bigger set is called the superset. So A is a subset of B and B is a superset of A. Supersets are written as this. So we read it as B is a superset of A. Okay, so let's move on to some examples. Can you write down all the possible subsets of this given set? So let's try. What are all the possible subsets? So we can take just one of these elements. So we can just take -1, we can just take 1, we can just take 0. So these are the three elements that can we take only one at a time and can form three sets. We can also take two elements at a time. So we can take -1 and 0, we can take 0 and 1, and we can take -1 and 1. And we can also take all the three elements. This will also be a subset of the given set, because the definition just says that all of these elements has to be there in this set as well. So that is why a set is a subset of itself. Remember that a set is a subset of itself because it actually caters to the very definition of a subset. The definition says that okay, if I have some elements which are also there in this set, then the first set is a subset of that set. So if I have two elements, so the definition says that if I can make another set with just these two elements, so it will still be a subset because all of the elements that belong to this set also belong to this set. So that's how it still satisfies the definition, and every set is a subset of itself. And finally, the null set is a subset of every set. So these are all the possible subsets that we can derive from this given set. I hope that makes the concept of subsets clear to you. Now let's take the concept of power sets. The power sets are nothing but the set of all the subsets of a given set. This is what we did just now, right? We were given some set A like this, and we made out all the possible subsets from that set. So all the possible subsets were -1, 0, and 1, taking one element at a time. Then we can take two elements at a time. And then finally we can take all the three elements. So these are the subsets. Now if we make a set of all these sets, then this set is called the power set of A, and is defined and denoted as P of A. So P of A is actually this bigger set, the set of all of the subsets of the set A. So that's just the power sets. Now a quick question, can you tell me how many elements are there in the power set of A? So A is having 3 elements, so the cardinality of A is 3. If you have forgotten what cardinality is, you can go back and watch my previous video on it. So the cardinality of A here is 3, and the cardinality of the power set of A is 8. So suppose that I give you a bigger set, suppose I give you a set B whose cardinality is suppose 5, then can you tell me what will be the cardinality of its power set? We'll look into it in a short time. Okay, some things you need to remember about subsets is that every set is a subset of itself. I just mentioned a few minutes ago that every set is a subset of itself because it satisfies the definition of subset. The definition says that A is a subset of B if all the elements that are there in A are also there in the element B. So this is actually true for the set itself, right? All the elements that are there in A are also there in A. So A is a subset of itself. An empty set is a subset of every set. So phi is a subset of any set A. And lastly, the total number of subsets of a set containing n elements is 2 to the power of n. So this is how we get the number of elements in the power set of A, because the total number of subsets of a set is nothing but the number of elements in the power set of a set. So power set is the subset, is a set of all the subsets of a given set. So the power set of A is the set of all the subsets of A. So the number of elements inside the set is actually the total number of subsets of the set A. So if suppose that n is equal to 3, that means the cardinality of a set A is 3, then the number of elements in the power set of A is 2 to the power of 3, which is 8. Similarly, if I give you a set with 5 elements, then the number of elements in its power set will be 2 to the power of 5 or 32. So that's how we can determine the number of elements in the power set of a given set, or equivalently speaking, we can find out how many total subsets can be formed from a given set. So let's quickly have a look at the proof of this particular thing. So suppose that we are having five elements. So the total number of subsets of this set which has 5 elements in it can be found out using combinations. If you don't know combinations as of now, don't worry, we have a video on it, go and check it out. So what we do, we can take one at a time. What we did was taking one elements out of those five elements at a time. So the total number of sets that we can make taking one element out of 5 elements at a time is 5C1. You can skip this section if you're not familiar with combinations. but don't worry, you will be familiar with it sometime, and you can revert here whenever you are comfortable in combinations. So the total number of singleton elements that can be derived from this set. So let's take up an example. Suppose that our set A is 1, 2, 3, 4, and 5. So the number of singleton subsets that we can form from this set is 1, 2, 3, 4, and 5. So we can take one at a time from these 5 elements in 5C1 ways, which will be actually 5. Then we can take 2 elements out of these 5 elements in 5C2 ways. Then we can take 3 elements out of these 5 elements. Then we can take 5C4 number of subsets, taking 4 at a time. And finally, we'll be taking all the 5 elements. So the total number of such combinations is 2 to the power of n minus 1. And you remember, if we don't take anything, then we'll be having phi as another subset. So we add 1 to it on both the sides, and this is how we get the total number of subsets in the power set of the set A. So don't worry if you're not getting it, you will be getting it once you are familiar with combinations. Just a simple straightforward thing, and I've used a formula from combinations that nc0 plus nc1 plus nc2 up to ncn is actually equal to 2 to the power of n. We will be learning this formula in combination, so don't worry about it. Now let A be given by this set. Which of the following are incorrect statements? And we have also to rectify each of these statements. Okay, so these kinds of questions can be really confusing at first, but just bear with me, we will try to understand each concept. So there will be 2 symbols you will be seeing over here. First one is the symbol of belongs to, and second one will be the symbol of subset. So belongs to is used to say that a particular element belongs to a given set. So for example, if I say that A is equal to 0, minus 1 and 1, then 0 belongs to this set. Also minus 1 belongs to this set and 1 belongs to this set. So that's the meaning of belongs to. The left hand side should be an element of that set. Make sure that you get it properly. The left side is an element of the set. Okay, the left side is an element of the set. So we write that this element belongs to this set. Okay, so now do you think that 2 is an element of A? That means, do you think that 2 belongs to A? So you see 2 over here, but this might get you confused. 2 is actually not an element of A, because it is actually the set that resides in this set A. It is not just 2. It is this set 2 that resides in this set. So actually this set belongs to set A, and this is not true. 2 doesn't belong to the set A. If it had been the case, we would be having something like this. But clearly this is not the case. We are having some brackets around 2. So 2 does not belong to A. Rather, this set 2 containing the single element 2 belongs to this set A. So we have to rectify it. So we can write it down as the set 2 belongs to the set A. Now question number 2. The set 2 is a subset of A. This is not the case, because this is actually an element of the set. If you want to say that the set 2 is a subset, then you have to write it down in a set itself. So this is an element and you write it down inside a set. Just like if I have to say that 1 is not a subset of A in here. In fact, the set 1 is a subset of A. The left hand side here is a set, and for these kind of operation or what should I say, these kinds of checks, we have to make sure that the left side is an element, and for this kind of a subset we have to make sure that the left hand side is a set. Okay, so let's move on to question number 3. 1 comma 2 is a subset of set A. This is also not the case because 1 and 2 are not individually there, right? So 2 is not individually there in this set. Had it been this like 1 and the set 2, this is there. These two elements are there inside set A. So 1 is there and 2 is there. So the set containing these two elements will be a subset of A because these two elements also belong to A. That's what the definition of subset says, that these two elements should belong to A as well. So then and only then that it can be called as a subset of A. Okay, let's take question number 4 now. 3 comma 4 is a subset of A. Again, this is incorrect because this is an element of the set A. So if you want to make it a subset, you will have to make the left hand side a set. For now, this is an element of the set A. Okay. Question number 5. 1 comma 5 is a subset of A. Now this is actually true because 1 and 5 are individual elements of A, and when we write it down in the form of a set, they become a subset of A. Question number 6. Phi inside a set, that means this is a set which is a subset of A. This is false. They are just trying to confuse you over here because phi in itself is a set. So phi is a subset of A. This would have been true. But when you write it like this inside curly brackets, that means phi becomes an element of this set, which is not the case. Phi is not an element of A. So this is incorrect. That is why we don't give curly brackets over here. We just say that phi is a subset of A. Okay, question number 7. 1 is a subset of A. This is not the case because 1 is an element of A. So 1 actually belongs to A. 1 is not a subset of A. And last question number 8. 1, 2, 3, 4 is a subset of A, which is not the case because 2 doesn't belong to the set. So this kind of understanding is quite okay, but how are you going to write this down in the examination? So you just have to mention, say for example, if this question comes in your examination, verify whether this statement is actually true or false, then how will you write it down in your examination? So you'll just have to take one element and show that it is not there in A, because if it would have been there in A would have been a superset of A. So if you can get hold of any one element which is not there in A, then this will be violated, because the subsets need that all of those elements have to be in the bigger set. So you can take for example 2 here. So 2 belongs to this set, 2 belongs to this set, but 2 doesn't belong to the set A. 2 doesn't belong to the set A. So you can write it down in the examination as 2 belongs to 1, 2, 3 and 4, but 2 doesn't belong to A. Hence, this is false. Okay, let's move on to the next concept of intervals. What are intervals? Intervals are subsets of real numbers. So suppose that I give you a real line over here. So we have 0, 1, 2 and so on, and negative numbers over here. So if I take any particular subset of it, say for example from -1 to 1, so this is called an interval. So I can take a set A of all those x's where x belongs to the set of real numbers and we restrict x between -1 and 1. So this is actually an interval. So this interval lies between -1 and 1. Similarly, there could be other intervals as well, from 0 to 2, from 3 to 4, from -2 to from -2 to 3. So all these are actually intervals. So let's suppose C is another set X, where X belongs to real numbers and -2 less than X less than 5. So this is from -2 to somewhere over here 5. Okay, so this is another interval. Okay, so the thing that you need to know in here is that there are two kinds of intervals. The first kind of intervals are called open intervals. Open intervals don't include the endpoints. Say for example, if we are having -1 and 1 over here, then -1 and 1 are not included in this set because this is not a less than or equal to sign. Had it been a less than or equal to, then -1 and 1 would have been included. But we are not including the equality here. So -1 and 1 are not a part of this set. So we represent it as -1 comma 1 open interval. If we had included the -1 and 1, that means if we had made these inequalities non-strict, then we would have written it as closed interval -1 comma 1, and this is called as a closed interval. So similarly, -2 comma 5 is an open interval and -3 comma 3 is a closed interval. All right. So there is just one more type of interval which is called as a Clopen interval. That means it is semi-open or semi-closed. So intervals like -5 comma 6, where open at -5 and closed at 6, this is called as a Clopen interval. That means it doesn't include -5 but it includes 6. So always remember that whenever you are having a square bracket, that means this number is included, and if we are having a round bracket, that means this number is not included in the set. So how are you going to write this down in the form of set builder method? We can write it down as the set X belongs to the set of real numbers such that -5 less than X less than or equal to 6. So this is how we write this interval -5 comma 6 in the form of a set builder method. Okay. Now express each of the following sets as an interval. So let's write down these sets as intervals. So the set A is equal to -4 comma 0, and it is open at both the ends because it neither includes 4 nor does it include 0. Had it been the case that it includes -4 and 0, we would have been having equalities over here, but we don't have equalities, so this is an open interval. Question number 2, 0 comma 3 closed at 0 and open at 3 because it includes 0 and it doesn't include 3. Question number C, it is 2 comma 6 open at 2 and closed at 6. Question number 4, -5 comma 2 closed at both the ends. Question number 5, -3 comma 2 closed at -3 and open at 2. Question number 6, -2 comma 0 closed at -2 and open at 0. Okay. Now let's do the reverse. We are given the sets in interval forms and we need to write them down in set builder forms. I'll just do 2 of these for you and leave the rest for you. So A is the set of all those x's where x belongs to real numbers such that minus 2 less than x less than 3. And the set f is the set of all those real numbers such that 0 is less than x less than and equal to 5, because we are having a square bracket over here and we had round brackets in these two cases. Now let's quickly recap of whatever we have discussed till now. We discussed the concepts of subsets and supersets. We discussed what power sets are. Power sets are the power set of a given set is the set of all of its subsets, and intervals are the subsets of real numbers. There are three kinds of intervals: open intervals, closed intervals, and Clopen intervals, also called as semi-open or semi-closed intervals. So finally, thank you for watching this video and bearing with me. I'll strongly recommend you to go hard, go and study hard, and decode all the mathematics that you have never understood. Thanks a lot. Bye bye. Enjoy.